Hey guys, Mr. B here. In this video, we're going to be going over the Chapter 18 review guide for ecology and climate change. All right, starting off with 18.1, what causes climate? Number one, which of the following factors does not affect temperature? All right, so of all of these choices, the one that does not affect the temperature in a location is precipitation. Latitude is how far away from the equator you are, north or south, so that has an impact. Altitude is if you're up on top of a mountain or down in a valley, that has an impact on temperature. And how close you are to a large body of water also has an impact. So precipitation, the amount of rainfall, that does not have any impact on temperature. So number two, which of the following temperature zone is the United States found in? So the United States is primarily found in the temperate zone. Okay, so remember that this is the zone that is kind of in the middle between the equator and the poles. So you have the tropical zone at the equator, you have the polar zones at the top and bottom of the planet, and then in between that you have the temperate zone, which is where most of the United States sits. So number three, which of the following is a factor that affects precipitation? So this is again the amount of rainfall that falls, and this is going to be prevailing winds. So prevailing winds are winds that blow in a certain direction in different areas. And so these are usually things that are going to carry water with them and then deposit it in certain locations. So that affects the amount of rainfall that location gets, or precipitation. Number four, the land on the blank side of a mountain range usually receives little precipitation. So this word we're looking for is the leeward side. Okay, so the land on the leeward side, that's the back side of the mountain range, typically receives very little precipitation. The windward side of the mountain, that's the side that the wind is blowing onto. That side is going to receive a lot more precipitation because that's before the water has fallen out of the air. Remember, it rises up the mountain, falls out of the air, and then as it gets on the backside, it's a lot drier at that point. So number five, true or false, mountain ranges in the path of prevailing winds influence where precipitation falls. That is true, 100% true. Number six, the seasons on Earth are caused by. So remember that the seasons on Earth are caused by the tilt of the planet. Okay, so Earth is slightly tilted on its axis, which is the reason why we have seasons. Has nothing to do with how far away the Earth is orbiting around the sun, or its speed, or its climates. Nothing along those lines. Number seven, how does climate differ from weather? So long term, or like long explanation short, climate is an average of temperature, precipitation, weather patterns, etc. over a long period of time, whereas weather is a short-term, more of a day-to-day kind of thing. So say that climate is a long-term average of temperature, precipitation, and weather patterns in an area. Weather is more short-term, day-to-day. Okay. Number eight, explain how temperatures range in the temperate zone compared to the tropical zone. Okay, so in the temperate zone, which is of course where we live in here in Minnesota, temperatures are going to go from very hot in the summertime to very cold in the winter, right? We have seasons. In the tropical zone, they don't have seasons. It's basically warm and sunny all the time. So we can say in the temperate zone, the temperatures vary, or let's say the temperatures range from very warm / hot to very cold / cool during the different seasons. In the tropical zone, they don't have seasons. It is primarily warm all the time. All right. Number nine, true or false? Plants and animals today probably need different conditions to live than plants and animals in the past. That is false. Okay, we know that one of the main principles that scientists use is that plants and animals today probably needed the same conditions that plants and animals in the past needed. So that is false. Number 10, true or false? From pollen data, scientists can infer that an ancient climate was similar to the climate where the same plants grow today. Yeah, this is true. So this is basically saying that, is it possible to look at pollen and assume or be able to tell that an ancient climate, a long time ago was similar to what a climate was today? Yeah, that's what pollen is used for. We use it to determine what climates used to be like. So number 11, Several narrow tree rings in a row would tell you that an ancient climate was. So if there are several narrow tree rings, that means that the tree probably was not growing very well. So that climate was probably very dry and temperatures were low. So it's going to be A, very dry and very cool. Okay. If it was wet and warm, that'd be a good growing season. You'd have thick tree rings. Very humid and dry. It's possible, but if it's humid, there's water vapor in the air, so there's probably water in the ground. And very hot and long. Again, warm temperatures aren't necessarily the worst. And if it's long, that also would mean that there's a lot of sunlight for a long time. Excuse me. It's good for growing. So it's going to be dry and cool. Number 12. Earth's history is full of climate changes, alternating warm period and cold periods called. So the cold periods are what we call glacial episodes or ice ages. Okay, that's what we're looking for here. Number 13, which of the following would be a natural cause of climate change on Earth? So we talked about different things that cause climate to change on Earth, whether it be natural or not natural. And this one, which of the following could be a natural cause of climate change, would be changes in the amount of solar energy that we get. So remember that the sun's energy does fluctuate, so that can cause natural changes in Earth's climate over a long period of time. Number 14, explain how an ice age may alter the geographic characteristics of the land. So ice ages, of course, are times where there's large, very thick sheets of ice that cover very big portions of the landmass. Excuse me, I'm sorry. So how that can alter the geographic characteristics of the land is that ice is very heavy, okay? It pushes down on the ground, causes the ground to buckle and bend and fold. And so as the glacier melts and recedes, there's going to be lots of valleys and low parts of the ground where the ice is pushing down, and that will fill in with fresh water as the glacier melts and essentially make a lot of lakes and rivers. So we can say that the geographic characteristics, there we go, of the land will change during an ice age because the ice will push the ground down and cause it to buckle and fold. This will create valleys and low spots, which then can get filled in by the fresh water when the ice melts, creating lakes and rivers. There we go. All right, number 15 in chapter 18.4. These two events can cause short-term climate changes and are a natural part of Earth. So we talked about El Nino and La Nina being two things that cause short-term climate change and are natural. They just come every few years. Number 16, El Nino is a blank water event, while La Nina is a blank water event. El Nino is a warm water event, while La Nina is a cold water event. So this is A. Number 17, the gradual increase in Earth's atmospheric temperature is known as, so this is global warming. Okay, now remember we've been talking about climate change in this chapter, which kind of encompasses lots of different things, not just temperature, whereas specifically increasing temperature is what we call global warming. So 18, scientists think that this gas is the main factor contributing to global warming. This gas is carbon dioxide. Now, it's not the only gas that we think is contributing to global warming. Methane is another one, but carbon dioxide is the main one. Number 19, this increase in human activity contributes to increasing levels of greenhouse gases in the atmosphere. This is going to be burning fossil fuels. It's a major thing that we humans do that is not natural, doesn't typically happen in nature, that releases large levels of carbon dioxide, which is a greenhouse gas. Number 20, ozone is an important gas in Earth's atmosphere so ozone's job is to absorb UV radiation from the sun. It's very important. If it wasn't there, we would not be able to go outside on land because there'd be solar radiation that would just essentially bake us and we would just die. So number 21, true or false? So greenhouse gases are gases that absorb heat from the sun, such as carbon dioxide, methane, and water vapor. That is true. That is exactly what greenhouse gases do. So true. 22, true or false? Greenhouse gases are a pollutant and have created a hole in Earth's ozone layer. That is false. Okay, now you might consider greenhouse gases to be a pollutant, and the fact that there may be too many of them, but they have no impact whatsoever on Earth's ozone layer. So that is not true. 23, what effect have human activities had on the ozone layer? So we know that humans used to use chemicals called chlorofluorocarbons, or CFCs, that ultimately created a hole in the ozone layer. So those are the human activities that were that had been done, and that is the result of it. So what effects have they had on the ozone layer? We can say human activities and the use of chlorofluorocarbons, geez, or CFCs, have caused a hole in the Earth's ozone layer. Okay. All right, and this last stuff is on the carbon cycle. Now, this wasn't specifically in the textbook notes, but this was in a video that you had to watch. So if you watch that video, this is all basically going to come from that. Okay. So what are the two forms that carbon takes on the planet? In that video, I talked about two types of carbon that we find, and it's going to be organic carbon and carbon dioxide. Okay. Remember that organic carbon is carbon found in living organisms or things that used to be alive. And carbon dioxide is a gas, typically found in the atmosphere, but it can also be found in the oceans dissolved. Number 25, what is the process where carbon is released? I apologize. What is the process where carbon is released from fossil fuels into the atmosphere? This is going to be burning. So this is where we humans burn fossil fuels, release it into the atmosphere. Number 26, what is the process called where atmospheric carbon is turned into organic carbon? So there's only one organism on the entire planet that can take carbon in the atmosphere, carbon dioxide, and turn it into carbon that is now part of a living organism, and that is plants. That process is known as photosynthesis. Okay, we humans cannot take in carbon dioxide out of the air and turn it into part of our body. That would be great. In which case, that would be how we get our food. But unfortunately, we can't do that. So only plants can. Number 27, what organisms are capable of converting atmospheric carbon into organic carbon? Oh, gotcha. I was like, this is like the same question. This is called producers. But we did not talk about this. So you know what? We are not going to worry about this question. So I'm just going to cross it off. It's probably actually not even on your sheet, so we're just going to delete it. Number 28, what is the process called where organic carbon is converted into and released into atmospheric carbon? So this is where we take organic carbon, part of a living organism, and it gets released back into the atmosphere as carbon dioxide. This is done through cellular respiration. Okay, that's where we breathe out every day, and every time we breathe, we are releasing organic carbon, which used to be part of our body and is now carbon dioxide, and it's released into the air. So, all right. 29, what are some seasonal things that may affect the levels of CO2 in our region? List two things that release CO2 and list two things that absorb CO2. All right, so throughout the carbon dioxide video, there were, we talked about the different processes that release CO2 and take it in. So we're going to talk about, here in Minnesota, what are some things that give off CO2? What are some things that take in? Okay, so one thing that releases CO2 here in Minnesota, of course, is fossil fuel usage, right? Cars, power plants, stuff like that. So you say item one that releases CO2, we'll say cars, right? Because they burn fossil fuels all the time. Another thing that can release CO2, we mentioned, was power plants, right? To power homes. Living organisms themselves, like us humans, breathe out CO2 all the time. So we can say, let's say power plants take power. As for something that absorbs CO2, so there are not many things that take CO2 out of the air, but one of the main ones, of course, is plants and trees. So item one that absorbs CO2, we say plants / trees. They do photosynthesis all the time, and so they pull carbon out of the air. Another item that absorbs CO2 that was mentioned in the video about carbon cycle was the ocean. Now, granted, we don't have the ocean here in Minnesota, But CO2 dissolves into water very easily, and although we don't have the ocean, we are the land of 10,000 lakes. So lakes and rivers, but primarily lakes here in Minnesota, absorb a lot of CO2 out of the air as well. Okay, so we'll say lakes. All right, number 30, what are the 4 main carbon reservoirs? So the carbon reservoirs are the locations or the places where we find most of the carbon on planet Earth. There were 4. Okay, the first one was the atmosphere. So atmosphere, or we can say atmospheric carbon reservoir. The second one was the fossil fuel carbon reservoir. So we find a lot of carbon locked away as fossil fuels. So fossil fuel carbon reservoir. Third one was the biosphere. That's all living organisms and dead organisms. So we'll say the biospheric carbon reservoir. And the last one was the ocean, right? A lot of CO2 gets dissolved into the ocean as gas, or there's living organisms that live in the ocean that have carbon in their bodies. So we'll say the oceanic carbon reservoir. All right. And then, oh, we did not do these in red. We should do that. All right, let's do this. Oh, maybe I can't do it that way. All right, that's fine. We're just going to change these all to red. I apologize for not changing these to red earlier. That was my fault. I should have written them in red. All right, so the last question here, as I'm highlighting these in red, number 31, what types of plants are best at absorbing carbon from the atmosphere and then storing that carbon over a long period of time? All right, so one, we know that the things that can pull carbon out of the air are plants, right? So it's going to be either letter A or letter B or letter D. So those are plants. We also know that if you think about annual crops, okay, these are things like corn or things that grow in the summertime only, versus woody perennials. These are like big woody trees, right? Maple trees, oak trees, elm trees, and house plants. So, you know, think of like flowers that kind of grow in your house or maybe die after a little bit. Of these 3, which is going to be the main one that's going to hold and store carbon for a long period of time? So, you know, years, essentially. Of these choices, it's going to be B, okay? Woody perennials or trees. Annual crops like corn, stuff like that, certainly bring in a lot of carbon dioxide when they're growing because they need that photosynthesis and that food to get bigger. But crops don't grow all year round, right? They only grow for a few weeks or whatever, and then they get chopped down, and that's it, and they're done, and then they don't grow again until the next season. Houseplants also are maybe around for a few years or maybe a year or 2, but then they die. They don't last that long. Trees, right? Woody perennials, trees, oak trees, maple trees, elm trees, they live for a long time, right? 30 plus years. They bring that carbon dioxide inside their trunk as they're growing, and then it kind of stays there until the tree dies or gets cut down. Okay, so it is going to by far be the best at sealing and storing that carbon away for a long period of time. All right, guys, so that is it for the Chapter 18 review guide here on ecology and climate change. Hopefully that was helpful. But again, if you have any questions, as always, you can reach out to me and I will help you. So, all right, that's it. Next up, you have your test. So good luck with that, and I will see you in the next video. Bye.